I'm Raymond from period 6, and I was assigned question number 7 from the 2019 AP exam. Number 7, a student dissolved a 0.139 gram sample of oxalic acid, H2C2O4, in water in an Erlenmeyer flask. Then the student titrated the oxalic acid solution in the flask with a solution of potassium permanganate, which has a dark purple color. The balanced chemical reaction equation for the reaction that occurred during the titration is shown above. So part A, identify the species that was reduced in the titration reaction. Justify your answer in terms of oxidation numbers. So we know our oxidation numbers just from a bunch of practice. So we know hydrogen is going to be +1 and oxygen is -2. And since it's a negative overall charge, manganese has to be +7, and then oxygen's -2, hydrogen is +1, meaning carbon must be +3, and then oxygen is -2, so that's +4, carbon -2, +1, and then this one's just +2. So it's asking for the species that was reduced, and we see that happens when the manganese from here to here changes by 5 charges, and it becomes more negative, and we know our acronym oil rig, and so the one that's reducing is the one that's gaining more electrons, so it's becoming less positive. So we know that the manganese is the one that's being reduced. So I'm going to shift it over. A, I would write MnO4- is reduced to Mn2+ because the charge of manganese in MnO4- is +7, and it ends up gaining 5 electrons to become Mn2+. Okay, so that's part A. Part B. The student uses a 50 milliliter burette to add the potassium permanganate to the oxalic acid solution until a faint lavender color was observed in the flask as an indication that the endpoint of the titration has been reached. The initial and final volume readings of the solution in the burette are shown below. Write down the initial reading and the final reading and use them to determine the volume of KMnO4, potassium permanganate, that was added during the titration. Okay, so the initial would be, it would go down 3, 3.1, 3.2, 3.3, and it's in between 3.3 and 3.4, so it has to be 3.35, and we go one more decimal place than the tenths place because we're given the line for tenths, so it should be 3.35, and in the final, it goes to, well, it's past 29, 29.1, 0.2, 0.3, 0.4, 0.5, and it's in between 0.5 and 0.6, so it should be 29.55, and this is all in milliliters. So, what focus? So it's asking for, determine the final volume of KMnO4 that was added to the titration. And so you do 29.55 minus 3.35 milliliters, which is just final minus initial, and you get 26.20 milliliters. And you can use the calculator because it's the long response section. So yeah, but I don't think you need a calculator for that. C, given that the concentration of potassium permanganate was 0.0235 molar, calculate the number of moles of MnO4- ions that completely reacted with the oxalic acid. So we know molarity is moles over liters, so we do 0.0235 moles per 1 liter, multiply that by the volume we just got, which would be 0.02620 liters, and the units cancel out and we get the number of moles. We use a calculator and you get 0.02, and you get to 3 sig figs, I would get 6.16 times 10 to the negative 4 moles. And you box that. And then final part. The student proposes to perform another titration using 0.139 grams sample of oxalic acid, but this time using 0.00143 molar potassium permanganate in the burette. Would this titrant concentration be a reasonable choice to use if the student followed the same procedure and used the same equipment as before? Justify your response. So we realized that the concentration decreased from 0.0235 to 0.00143, so it's really diluted, and because it's really diluted, we would need to add more of the potassium permanganate into the oxalic acid concentration solution to fully titrate it, and it wouldn't fit in this 50 milliliter burette, so we wouldn't be able to use the same equipment. So the answer should be no. This titrant concentration would not be reasonable because a 50 milliliter burette would not suffice, and the Km and O4 minus, oh no, not minus, molarity is too diluted. And yeah, so the grade breakdown for all of these, they're all 1 point each. So for the first one, I think all you would have to do is say that the MnO4 minus was reduced because it gained 5 electrons, or something along about how it changes in oxidation numbers by gaining 5 electrons or 5 negative charges. And for B, I think you would just get 1 point from getting the correct answer, which was really easy, just final minus initial, and you put it in as 29.55 minus 3.35, and you get 26.20 milliliters. I don't think sig figs matter in this case. And for C, it's also only 1 point, and you just get it from getting the same number and showing incredible work. And for D, it is also 1 point, so it's a all-around 1 point question. And yeah, I'm pretty sure you just get 1 point from saying no, and then something that is not wrong. You could say something about you should say something along the lines of it being too diluted for the same equipment as used before. And yeah, that's it.